Hello everyone, this is the second module of habitat and niche. In this module, we are going to emphasize more upon the niche. To recall, we can say that habitat is the place wherein organisms live, whereas niche is the role a species play in the ecosystem. The learning objectives of this module are fundamental and realized niche, Grinnellian, Eltonian and Hutchinson's view to understand the concept of niche, understanding the character displacement, geographical overlap and non-overlap concepts. Fundamental and realized niche. The niche is the set of ecological conditions under which a species survives and individuals reproduce. The fundamental niche is the set of conditions under which a species can exist, including physical conditions, vegetation and available resources. However, interactions with other organisms like competitors, pathogens and mutualists and the capacity of the species to disperse and establish limit opportunities to occupy the full potential range, resulting in a smaller actual or realized niche. A multidimensional cloud or factors of favorable conditions where a species can easily live and reproduce. Realized niche is a subset of fundamental niche where the species can persist in the presence of other species competing. This slide shows us the concept of niche construction through the natural selection process under available resources. The advanced and increasing refinement of the interaction between individual organisms, that is I, and the environment, that is E. From Darwin's conceptualization of the milieu as a selective filter to population level alteration in the A figure, to niche construction in figure B and to self-organization in figure C. This slide shows the fundamental and realized niches of different populations. Grinnellian, Eltonian and Hutchinson's view. The two concepts of niche, that is the Grinnellian and Eltonian, vary in kinds of variables used, such as dynamically linked requirements or relatively static conditions. The Grinnellian niche can be defined as non-interactive variables and ecological situations on broad scales, mostly physical variables, relevant to sympathetic coarse scale ecological and topographical properties of species. Grinnell included all commonly listed environmental limiting factors in his formal description of species or niches. These are microhabitats, abiotic factors, resources and predators. He emphasized upon the mixture of physiological and behavioral adaptations that allow species to react to such factors. He overtly tried to recognize the conditions that allowed a given species to exist by examining the merger set of conditions in all the environments where it was found. These concepts appear synonymous with Hutchinson's, which gave the theory in 1957 and 1978 fundamental niche, which he described as a multidimensional hypervolume describing the circumstances when organisms' expected utter fitness is at least 0 in a conceptual space where excess compromise all the environmental variables affecting that species. Elton used the niche concept in a different way to describe the impact that a given species has on the habitat, sometimes including the abiotic factors. He explains the niche as increasingly fine description of the role of a species in the community beginning with its trophic level. Alton's niche concept was familiarly related to the trophic pyramid of numbers, food chains and food cycles and framework of relative body size between predators and prey, explaining interactions among species. Elton summarizes that niches are essential because they enable us to see how different animal communities may look like each other in their basics of organization, the environmental variable and optimal range of population growth. Elton's view of the niche was more leaning towards describing how an organism affects the environment, primarily by consuming resources and relieving as resource for greater trophic levels, than in describing what environment factors affected the organisms. Eltonian niche focuses on biotic interactions and resources consumer dynamics, mostly biological variables. Eltonian niches are especially fine-grained and based on variables connected to ecological interactions and resource consumption. Both the variables can be measured chiefly at local scales to understand the niche of a species. Hutchinson defined the fundamental niche as a set of all the existing conditions of the environment which would permit the species to exist indefinitely. Hutchinson specifically included quantitative axes for every factor that could impact fitness. He used axes that served as quantitative descriptions of resources, for example, food particle size or distribution along a habitat gradient. Hutchinson's approach created problems in the evaluating the association between resources and fitness and could not deal with the resources that could not be described by simple quantitative axes. Later, he introduced the idea of a realized niche, in which the effects of competition, that is the biotic variable, reduces the fundamental niche of a species and the area practically it could occupy. Character displacement, geographical overlap and non-overlap. Ecological character shift describes a pattern where morphological variations between sympatric species are enriched through interspecific competition. The theory of ecological character displacement was first developed by W. L. Brown and E. O. Wilson in 1956. This theory is quite simple. Assume that the two similar species come into contact. If resources are limiting, the species are likely to contend strongly. One possible outcome is competitive exclusion. The superior competitor will achieve and the inferior one will become extinct. But another probability is that natural selection will favor, in each population, some of the individuals whose phenotype allows them to use resources not used by members of other species. The outcome may be that the populations diverge in phenotype and resource use, thus reducing resource competition and permitting coexistence. This slide shows the plant-insect interactions, which is a part of niche. The idea is simple: depletion of shared resources by closely related morphologically similar species would favor phenotypes exploiting new resources as yet unused, foremost in leading to divergence. Presented several examples in which beak differences between species were greater where they occurred together, sympatry, than where they occurred individually, that is allopatry. His most memorable case was of the two ground finches, Geospiza fuliginosa and Geosmiza fortis. Two species with partly overlapping geographic ranges might exhibit greater differentiation in sympatry than allopatry if each was responding independently to the same environmental gradient. The patterns might instead have been the outcome of the phenotype plasticity, which however interestingly is not character displacement. Ecological character displacement is defined as a process of phenotypic evolution in a species generated or conserved by resource competition with one or more coexisting species. The evidence for character displacement in nature is observational, experimental and predictive. By observational, it means as studies of pattern in existing species assemblage. By experimental means experimental test of predictions of character displacement, not experiments testing resource competition per use. Character displacement involves evolutionary shifts in character states in response to competition, but biased extinction of phenotypically similar species may yield a similar pattern. Character displacement arises from depletion of shared resources, that is competition, and hence a connection to resource use must be shown. The figure shows two sympatric species with mostly overlapping distribution of resource use. If resources are restrictive, then natural selection may favor individuals in each species with traits that allow each of them to use that portion of resource spectrum not used by other species as directed by the arrows. The result may be that the species diverge in trait value and resource use, thus dropping competition for the resources. To summarize this module, we can say that niche is an important factor of ecosystem. It is the role a species play in the ecosystem, including its various ways, unique ways to survive, how it interacts with the other organisms, and how it survives to attain its food, shelter, and avoids danger. For example, we can say like bacteria, it feeds on dead animals, keeping it away from piling up, helps in decomposition, and thereby provides nitrogen to the soil. Thank you.